Alright, so we're going to talk about the angle sum of polygons and working with them. Polygons are kind of fun. One of my favorite sections is this section. So to start off with, we have the definition of diagonals and sides. So sides connect consecutive vertices. So if you think about a square, right, there's four corners or four vertices. A side's going to connect the ones that are next to each other. Consecutive is a word for next to each other. So here's a side, there's a side. Hopefully pretty straightforward idea for you guys. The diagonals are going to connect the non-consecutive ones. So if I go from here to here, that would be a diagonal. Here to here, another diagonal. And both of these are segments, like they're actual lines, we can measure them, so forth. Quickly, they just want us to draw in some diagonals, which again, you can do from one corner to the other corner. What you should see when you're making diagonals is that you're cutting your shape into little triangles. So actually, if I just do one diagonal, you can see there's this triangle down here and triangle up here, and that's going to be important moving forward because we already know stuff about triangles, and we're going to use triangles to build up our polygons. Okay? So diagonals to divide polygons into triangles. We know the sum of triangles is 180 degrees. We've already been there. We've done that. What you can do, okay, you can multiply the number of sides of a polygon by 180 to find out your new shape. That's not quite true, but we're getting there. So we know our number of sides. We can figure out how it relates to 180. And we can do that by figuring out the triangles. So I have my square here. I cut it in half and I have two triangles. Here I have a pentagon. So I can cut it here and then send this one over here, and I'm left with three triangles. Finally, I have this hexagon, which is 6 sides. There's a triangle. There's a triangle. And there's two more. So 1, 2, 3, 4. So what we notice about this pattern, get rid of that yucky line, is that the sum of interior angles, this is our formula here, in any polygon, where n is your number of sides. So a hexagon had 6, a pentagon had 5. If I take my sides minus 2, i.e. 6 minus 2 is 4, 5 minus 2 is 3, and so on, that gives me my number of triangles. If I take 180 times the number of triangles, I will get the sum of interior angles. Okay, so I have this nice list going on here. I'm going to continue to fill it in. I have my type of shape, it's the type of polygon. Let's try to get to know some of these names. You'll see them on Apex. You can always refer to the list. If I take a triangle, I know it has 3 sides. I take my number of sides, 3, minus 2, well, that gives me my 1. Times 180 is 180. A quadrilateral, a square, something like that, it's 4 sides. 4 minus 2 is 2, times 180 is 360. And I'm going to continue on with this pattern. I know an octagon has 8 sides. If I subtract 2, I get 6. And 6 times 180 is 100. It's 180. Okay? Whether it wants to be or not. If I do 9, 9 minus 2 is 7. And 7 times 180 will give me 1,260. And if I do a decagon, that would be 10. Or that would give me 8. So 10 minus 2 is 8. And 8 times 180, sorry, calculator's being a little slow, is 144. And I could do this with any size shape. You might see like a 20-gon going on Apex. Do 20 minus 2 times 180. Our next portion. You have interior and exterior angles. Hopefully pretty straightforward. Interior angles are angles on the inside. So that is 1, 2, and 3 in this example. Exterior angles are angles on the outside that form linear pairs. So that would be 4, 5, and 6. I can count numbers, I promise. And what we know is that they are linear pairs. So I know 1 and 4 add to 180. So 1, 4. I know 2 and 5 add to 180, and I know 3 and 6 add to 180. So a little bit of review. But we can also have exterior angles with our polygons. And the rule for polygons is, come on, there we go. They add, and this is another big number in geometry, to 360. So the number of sides of interior angles equals the number of exterior angles. So there's the same number. All interior angles and exterior angles for right now, for a regular polygon, will be congruent. Your sum of interior angles is that n minus 2 times 180. The sum of exterior angles, you don't even have to do any fancy formula. It is just 360. If you add them together, you get 360. So if you want to find the measure of interior angles, you do that measurement from before, and you divide by n. And I'll show you that in a second. If you want to find exterior angles, you divide by n. Okay? These are nice and straightforward. I'll show you these charts because I think it makes more sense in a chart than it does as random words. A triangle. Triangle has 3 sides. Your number of angles is 3. Sum of interior angles from the previous chart was 180. So if I want to find the measure of each interior angle, I take my 180 from before, and I'm going to divide it by my n. Or no, sorry, not. It doesn't matter. They're the same. Number of sides, number of angles are the same. I'm going to divide it by n. Okay? Which in this case is 3. So 180 divided by 3 is 60. Okay? Not okay, computer, but hopefully that's not bad for you. Me and the computer will have our own words, apparently. Or not. Anyway. Okay. So, I can get this back. So I did 180 divided by 3, which gave me 60. Okay, 60. I swear. Now to do the exterior angles. This time I start with this 360. 360. I still divide it by 3. I believe that is 120, if I'm thinking correctly. 360 divided by 3, yes, 120. So there's that, and I do this with each shape. When I go to quadrilateral, my sum of interior angles, so 360, is 4. Well, what is 360 divided by 4? It'll equal 90. And this one's actually the nicest one because they're both the same. So 360 divided by 4 is still 90. If I do my pentagon, my sum of interior angles is 540. And I'm going to divide that by 5. So 540 divided by 5 is 108. And I can put that in. But now, be careful. For exterior, I always revert back to 360. And I'm going to divide that by 5 this time. And I'll stop there on this chart, and we'll just discuss this more tomorrow in person. I hope this makes sense. Hopefully it's pretty easy. And I'll see you tomorrow.